If I do it on the computer, it might not be an issue. Said recording already? Yeah. Okay, cool. So everything you need is here. And I will go through it in some detail. But before I do that, let me just mention a couple of things. This is the link for the slides that has all of the other links that you will need. Let me give you a chance to write it down in case you haven't. Raise your hands if you have not gotten the link. Okay, so I'll give you a second. So for those of you who are connected remotely, let me see if I
put it in chat.
Okay.
No,
Okay, everybody have the link? Yes? Cool. Okay, so one of the things, I'll say a few things as we get going, and we will remind you of this, we will send you more email. But as we get to Mexico, one of the things that we want to do is we want to make sure that you got there and the person who was supposed to pick you up picked you up. We have incredible security. So the person that picks you up, as we might have mentioned to all of you, there will actually be a faculty member at the airport who will pick you up and drive you to your hotel. He will send an SMS, which will then be recorded. But we'll also encourage you to use this app. Some of us used it last year, and it works pretty well. It just lets you know that, again, you were not eaten by a shark somewhere, and you're still alive. Right?
Yeah, he's laughing and
Yeah.
saying, they're going to my country, what they're going to be. I could see in her face what face I was sending them.
For all the people in the country,
Yeah,
I know it's
sorry.
going to sound like we're crazy, but it's just, we want to err on the side of caution. How about that? So, and I know many of you have parents that will feel a lot better if they hear about the crazy security we have. So it's good, okay? I bet you no one in your family has ever used that, or my family for that matter, right? So, okay, another thing is we will come back to the question of data capture. There are a number of subgroups within the overall group that are looking at different things. Some of them are looking at research questions. Some of them are looking at data capture. One of the ideas that we have now is predictive models for some of the things that we do because of what I mentioned before. One of the things that we want to do as well is we want to capture photos, and we will expand on that. But I wanted to show you here, just for the purposes of inspiration, some of the pictures from last year. You can see these are from the first session on the weekend before the workshops. You can see here Kasturi, myself. This is in the city of Monterey. Some of the universities. You can see some of the TAs. There's Erica. Some of the instructors across the city. This is in Cholula, in Puebla. This is in Monterrey. Let's see. Many of the different groups. Is Olivia here? Olivia's not here, but some of you must have been interviewed by Olivia. You know, just pictures of the many different places around the country that started to come in on the stream, and you can sort of see here a lot of people doing many different things, many different classrooms. This is one of the tech companies in Monterrey, and this is me riding the skateboards. This is their offices. You know, they're you know, students having fun. That's not part of the program, but you know, you can. They had some amazing pictures of Mexico City. This is Puebla again. It just goes on and on and on, right? This is the food. You know, look.
Like
So,
something I ate.
yeah. This is me. I went to Puebla, and when it was time to take my plane, this was my plane. And this is how you load the, you know. So anyway, very pretty country. Hi, come on in. There's not a lot of spaces, but you can sort of see there's Olivia. There's the closing ceremony. It just goes on and on. But that's a link you have. So if you wanted to see a little bit more, you know, what people did and where they went and what kind of pictures they took. You can see there. This is what I mentioned. Now, everything I'm going to cover today, I'm sort of trying to recover from a cold, so I'm not at my most lucid. So everything that I'm going to cover today is in these 4 videos, and I will be walking through each of these folders. Each of these videos corresponds to one of the folders in the repo. So if we go back to this repo here, let me see. You'll see that everything's really slow on my machine. So if you take a look at the repo, you'll see that, you'll see that there are 4 main folders. Each of those folders correspond to one of the videos on the slides, right? And I go in detail throughout the entire day. Last year, I ran a small pilot 2 years ago, or 1.5 years ago. Last summer was the first time, and I did it myself with some of my grad students. And last year, I no longer participated in the teaching, and it was just all of you going to Mexico and doing the teaching. And so I was pretty high level in my approach, and I said, you know, generally here are the ideas, these are the things that you need to do. And as the workshop drew closer, a lot of people felt very nervous about what they had to do, right? They were going to teach an entire week, and they weren't sure exactly what they needed to do. So in response to that, I created this repository, and I created the videos. And I go hour by hour through the entire day, all of the activities, and all of the projects that are done in class. And so I won't go through it in detail today, but I'll point out some of the highlights, okay? And so that is pretty much the workshop. And so from here on out, what I'm going to do is I'm going to, I have music on. From here on out, I'm going to move to the folder that has all of this information, and I'm going to open it up. And as you'll see, I have some slides here that I'll come back to, or maybe I should, let me see what I have on the slides. Okay, so. So let me just say it. Your number one goal, your number one goal for the workshop is to be able to connect with the young women that you're teaching. All of you had an experience before coming to MIT where you connected with technical material that allowed you to see into a different career path to your life. Most of you come from families or backgrounds where this wasn't the obvious choice, right? And so what we're trying to do is we're trying to provide that opportunity for these young women in Mexico. These, you know, coming to MIT, coming to careers like the ones that you're on is not part of what is expected. And even speaking to the women, the TAs, many of the ones that are on the session right now, you'll hear these stories over and over again. Even from MIT students, PhD student for computer science last year, for example, she mentioned to me, taking a computer science class in my high school was a decision on identity. You know, if you went and took, you know, AP English, there wasn't any identity that you were choosing. But if you went and you took AP Computer Science, that meant something. It meant something very clear. And so it wasn't an obvious choice. And so when it comes to the young women in Mexico, this is not really part of what is expected of them, what they see other women choosing. And I know Grecia is here, and she is different. I'm going to pick on you now. But for that matter, you know, I'll point it at myself. It was the same situation, right? I'm a kid that grew up in northwest Mexico, on a Spanish colonial town, where everybody there, you know, was obvious where they were going to go to university if they were going to go to university. Because, when it's time to go to university, you go down the street and you sign up at the local university. Nobody's going anywhere else. Why would they, right? Doesn't make any sense. And so when it comes to your breadth of opportunities and perspective, and you probably heard us say at some point, if she can see it, she can be it, right? In the sense that you have to be aware of what a possible dream might be before you can start to aim or point in that direction, right? And so your being there is part of that. And so the very first things that we ask you to do is to be open, to share your experience, to share your life. I say to let them see you, right? For more than just the MIT nerd, right? That's not even a concept that they would understand. But to let them see you, that you like art, or that you like dance, or that you watch anime, or whatever it is that you do, just to humanize you, right? And so that they can see you're somebody real, somebody with interest, and that they can connect with you. And so, as I mentioned, your primary goal is to be able to let them have a connection and to let them see into a possibility of a different life, right? Because that is what is most scarce. And as you know, even within the United States, as I say this, you could go many places, and I have to stay here because of the cameras, right? But you can go many places where this would be true. So in the developing world, this is even more so, right? And so that is the number one priority. Second one, any guesses as to what it is? Security, right? Be safe, right? Okay, so with that, let me go ahead and open up the folder for Monday. And as you can see here, I have a number of things. And I have made each one of these folders. It's very much an MIT hacker style approach, right? It's a bunch of stuff in a repo that you will clone to your desktop. Raise your hands if you have not cloned a repo. I know some of you come from very different backgrounds, okay? So it's okay, right? So a GitHub repository. So I know there's computer science students and there's Sloan students here, and so there's a pretty wide breadth of backgrounds. But if you have not seen it, GitHub is a place to work in a team in a collaborative fashion. There's a lot more to it than that, but for now we can leave it at that. If you've never used it, don't worry. You can just go there and right-click on the folder. Let me see, did I close it? Yeah, I think it went away somewhere. But if you follow the link, you can go there and just download the zip, and you'll get everything. So you don't need to know anything about cloning and all of these other things, right? But for those of you who know, you can. There's a number of things that you'll find in the folders. Part of them is code. Part of them is slides. Part of them is just my own cheat sheet. And I'll open that up now. You can see here there's a README. And you can see here there are a number of tasks, right? And so I guide you through the entire day. I start off with an icebreaker, introduce yourself, etc. And I believe I have some slides. And I also have some slides to the very same tasks. And let me go ahead and open that up. And I'm trying to get rid of all Microsoft in my life. So this is an actual PPTX, but I'm opening it with the Mac equivalent. So this is Monday. The very first activity that you will do is to create teams. Don't explain what you're going to do to avoid them. They're going to come from very different socioeconomic backgrounds. We're making a pretty strong effort. There's a lot more to it than that, right? But we're making a pretty strong effort to try to keep the classroom 50-50. That means half of the women come from private schools and half of them come from public schools, typically from poor areas of town. Because of that, you're going to get this bunching, right? Before you walk into the classroom, they don't know each other, and so they'll all be quiet. There's really no talking. They're sort of shy. And they'll be grouped by the places that they come from, right? And so have any of you ever done the number yourselves 1 through 5 exercise, and you try to get people? And so if you do it quickly enough before they can adjust, right, and they position themselves to be able to stay together, you'll have an opportunity to create random groups, right? And that'll be good. One of the things that surprised me about them is that once you created these groups, although they hadn't met each other previously, within the next 5 minutes, it was just complete cooperation, and all of them were working together, and there really weren't any obstacles to them coming together as a team, and they collaborated seamlessly every single time we created a team. And so this was sort of unusual and quite nice to see, right? The other thing, as I mentioned, as you get started, and this is the other thing that I'll say, remember the number one goal. The number one goal is to connect with them. Because of that, there are a number of exercises that you will see here, and it is up to you. Nobody's going to be looking over your shoulder. You are in charge of your classroom. Everybody's looking to you for leadership, right, and authority. And so it is up to you to decide what makes sense. On anything that I'm going to mention, if this feels like it's the wrong thing, pivot, right? Pivot and do something else. Your goal is not to saturate them, not to make them a computer scientist over a week. Your goal is to connect with them and to allow them that opportunity to connect with these wonderful ideas that we dedicate our lives to, right? And so because of that, this is one of the activities that I did, right? So introduce yourself, as I mentioned before, you know, where are you from? What do you do? We have a really diverse group. We have people here from, you know, India. We have people from China. We have people from pretty much everywhere you can imagine, just like MIT, right? And so they are very curious. They want to know, and they'll ask you all kinds of questions. And they're very warm and very open, very friendly, right? So it's a great thing. Then do the same thing for them. Allow them a chance to introduce themselves. This is here a little bit sensitive sometimes as to where you live. Anybody know why?
We're in neighborhoods.
Yeah. So you're sort of showing colors there, right? If you say where you're from in your city, and there can be some sensitivity. So that's why. The other thing is to ask for hobbies. The women in general tend to love artistic activities a great deal. The most common hobby was dance. Kasturi did an exercise, it wasn't quite dance, but where she did loops physically, and people were moving around and so on. And we were discussing the possibility of doing, you know, Turing complete the conditionals and looping and so on with dance routines. Because if you start to think about it, it's very similar, right? And it makes it really accessible. How many of you have ever learned Turing completeness in terms of choreography? I don't think anybody has, right? But it sounds fun, right? And so that's sort of, again, that's the spirit, right? It's these simple ideas that are really powerful. How can we make them fun? Right? And so this is why we asked some of this, and you know, just to again break the ice, let them see, right? The other activity that we do as an icebreaker, we ask them to draw scientists. You can imagine what this is. The result of this is, right? If you took a room of random people and you asked them to draw scientists, what is it going to look like? Yeah. So the older white man with no hair and the left hood, right? So we run through this, and we do it at the end as well. And this is one that we collect, and that we compare the beginning and the end, right? This is just part of that data collection. We then start off with what is a pattern. In Spanish, the word patron or patrones can mean boss as well. And so the first times I asked the group is, what is a patron? They said boss, right? Sounds good, right? But it's a fun discussion to have. And here what you're trying to do is you're trying to get them to come to the realization that they are already engaged in a large number of patterns. They're not recognizing it, they're not labeling it that way, but even looking for an address walking down the street, right? You're doing OCR, you're doing number recognition. There's a lot of things that you're doing, right? And so we went through all of this, and we had a pretty open discussion, right? And it was a lot of fun. Some of them sew, right? And because of that, they knew the word in Spanish for patrones. Patrones is something that you put over, you can buy these patterns if you're into fashion, and you can put them over cloth, and you can cut around them. You can make dresses, and so this is something that many of them are also familiar with. And so it was a nice way to start thinking in terms of patterns, right? One of the things that most of you have, even if you haven't had this discussion, is you have a lot of clarity in thinking. It sort of forces us, right, this system that we go through. And starting to share that clarity and that vision is part of the mission, right? The other is, how many of you have seen, raise your hands, the restaurant as a computer analogy? Raise your hand. If you haven't, and almost no one has, it's a nice way to introduce the parts of a computer, right? You have somebody who's taking the messages back and forth. You might have permanent storage, which is the cook, bringing the recipes out of some box. You have the cook, that could be the CPU, also executing the recipes, and you have that, that content coming back then to the table. And there's a lot of things that can be presented and discussed in that manner, right? And so again, it's a non-threatening things that they've done already, with their parents, and you can start to engage them in that conversation, right? Like, what do you do? What do you observe? And people like to go out and so on. The next exercise in the morning is one of the most popular ones. It's maximizing happiness. And let me see what my next slide is. And we we first called it how to find a boyfriend. And believe it or not, the parents complained. And so we then changed it to how to find a friend. But what we're doing is the Gill-Shapley algorithm, and the way in where, and this is going to go fast, and you won't get all the details, but I'll just overview it. There's a scoring system. If you get your first preference, you get 4 points, and so on. If you get your fourth preference, you get 1 point. And there's a number of preferences that are given, and we do the preferences with cards of kings and queens. And I know about the heteronormative problem with this, but we're in startup mode. We will come back to that later. At this point, we're going with the traditional. And so you can see here the list of preferences. And so the goal is to be able to maximize the happiness of this dating pool, and it's the common combinatorial explosion, right? And so you first ask them to solve this problem without any guidance. You say, this is a common scenario, right? You like a boy doesn't like you, or whatever it might be, right? Right? Or the other way around, right? And so if you wanted to maximize the happiness of the group, how would you do it, right? And so you give them an opportunity to do this, right? And they'll have the materials in the classroom, they'll have the cards, you'll show this on the screen so that they can write down what the preferences are. And they'll walk through this, and they'll try to maximize, and based on those rules that I mentioned, to try the highest happiness, right? And so they compete, you make it, one of the best techniques when it comes to learning is gamification. And so you make it so that the first one to get the highest score, and that it's a valid score, you'll recognize them. The first year gave them wristbands, but because of the numbers, we're going away from the wristbands because, again, logistics problems, right? And so we allow them to do this, and you can see here them working through the problem, adding up the numbers and so on. We then after and this takes them from beginning to end, this will take over an hour, right? And your job is to go around the room with the TAs to make sure they're doing it right, to answer the questions and so on. And then you come back and you give them the algorithm, right? The stable marriage algorithm, Nobel Prize winning, algorithm of Nash, and I forget who the other person is. And then they can solve it quickly, right? It takes 2-3 minutes, and they can see the solution. And so, they get excited about that because they struggled, and then they can do it pretty easily, right? And then the next thing that they do, and this is something that we do often, is to ask them to apply the same algorithm now, but to something of their own choosing, right? And this isn't one of those algorithms that really has wide applications. So for example, you could use it for admissions. right, in a national school system where you have multiple schools and they have all of them a certain preference of students. The students have certain preferences of universities, and you could design a national admission policy where people would be happier than if you just did it in, in the typical way in which it's been done, right? You can apply it to, it's even been applied for organ donation. In the UK, there's been applications of this algorithm, and it's something that's widely used. And so we give them an opportunity to think through how they could do this. And that's where they really come alive, right? Because you're opening it up to their framing of the problem and their application of this algorithm. Some of the ones that come to mind are somebody was trying to do this to minimize the number of kids in orphanages and parents looking for kids as well. But all kinds of wonderful applications, right? And so this is one of those problems that really opens up the creativity for what they want to do. They're very graphical in their approach to the problem. Without us prompting them, they tend to go up to the whiteboards as a group, 4 or 5 of them, and they start to draw and just think through the problem, right? And so this is something that they do, again, for quite a while. I'd say 40 minutes or 30 minutes. And then you do presentations. You ask each of them, and they're not shy. That's the other thing. They're quite confident. You can see them in the videos. They'll stand up and they'll present their idea or their solution. And certain leadership starts to show up as well, within the groups. But they'll, let me stay here within the cameras. Any questions coming back from Pushpita or Esther? No? Good. And so you'll go around and ask every team to present, and every team will present, and instead of having slides or something like it, they'll just walk through the design that they made on the board. And that's something that they do throughout the entire week.
Since you just asked me, I have a clarification that when we do this game something, we kind of play bigger cards. So we kind of have like one big point card and one small king. We try to see that everybody gets stationery and every team gets something. Last time we had less. So what I did was I was sharing with another person, another instructor on my team. So we decided, hey, you do it like the first hour and then I will do it in the next hour. So sometimes you don't get all the stationaries available. So just try and like balance with each other. There will be no campus, you will be alone. So you'll be having another MIT or somebody from LSD or Stanford with you. So just kind of share those things because sometimes stationaries are really short. We don't get to buy a lot of stuff. So yeah.
That's true. Yeah. The environment, and this is getting bigger and bigger, right? And so the control is not as high as when we were a smaller group, right? In the sense that we could be sure that the materials that you were going to arrive to class with were going to be exactly what I'm showing on the slides. There were places last year where there were no materials or for, say a certain activity. And they improvised. They had a stack of white paper and they just made the card themselves, right? The TAs made them in 5 minutes while they were doing another activity, right? So this is something else to be mindful of. Your classroom might be not exactly what you want. And it's just part of that challenge of going out to, all over the country, many different universities, many different environments, right? For the most part, there weren't any big challenges. The biggest challenge that I saw was that somebody had to teach in a cafeteria for a day. That wasn't great or fun, but after that, they were back to the classroom, right? And it's just one of those things that,
Yeah, we took up like grounds because the classroom was not ready or cleaned up, so we just sat outside on garden field. This is 20 people, so it's not too large, so you can still have like a contact with everybody and have a good communication.
Yes. And the TAs are great, right? And so they'll help you. That's another thing. If you, as we get bigger and bigger, there will be the anomaly, right? There will be the person that has the problem child, right? We haven't had it yet, right? But what if you have it? My advice is the TAs are really good, like at handling pretty much anything. They're local. They know what's okay, what's not okay, and they take care of problems really, really well. Like even
so
before you see
TAs who are listening to us.
Yeah, that's right. That's right. So I'm praising the army in Mexico of people that are there, right? So yeah. And a lot of them have a great deal of experience, meaning they've, done babysitting, they've taught in summer programs, they're pretty experienced, right? Okay, so then, although I didn't mention it, in the morning, there will be no computers in the classroom. As you saw, it will be just chairs and some of the pictures that I showed. It is pretty much everyone on the same level because we're talking about pretty high level ideas and none of them have really seen them before. Now, when it comes in the afternoon, it's traditional computer lab, hands-on keyboards, and there you can start to see the differences pretty well. Kasturi had a case where some of her students had never used a computer before, and so she had to go through the exercise of showing them how to save a file. And so you can imagine when you have somebody that's their first experience side by side with someone who potentially has been using a computer for all her life, right? And so you start to see some of the big differences. There's a number of ways to address this. I tended to do harder problems. If you were done, okay, now do this, right? And I had a pretty good reserve to problems that I was sure nobody would do, right? The way Kasturi did it, I believe it was you, is that if you finish first, then help your peer, right? Is that what you're doing? And I like that better because they tend to speak, and this is not a language, English, Spanish, it's just the language that they use is not as specialized as ours, right? And they feel more comfortable and not feeling stupid and asking a question, right? And so this help your peer if you're done, I really like that. And it seems to work really well in the classroom, right? And it keeps everybody busy and engaged. And as you know, explaining something really teaches you a lot more, right? And so it's a good opportunity to go deeper, right? So in the afternoon, this is the first day. You'll have to remember, you only have a week. You don't have that much time, right? And so how are you going to share some of the concepts of computational thinking is a challenge. And so you can see here where I started, I talked about the blank page, and we're going to be running on top of the browser. And the reason to run on top of the browser is because infrastructure becomes a very big deal. And for example, just having the right version of Python installed on all the machines across the country would be just a nightmare, right? And so running on top of a browser means a zero configuration environment. Earlier work I did as well in India and other places sort of led me down this path. So the very first thing that we do is, I show them a blank file that I load onto the browser and nothing happens. And then I write a string onto that file, and you can see that that shows in the browser. And then I start to give it some formatting, and they can see that the browser is interpreting this file, right? And we can see there then the evolution of some of the instructions that we're passing to the machine. The goal of the first day is to do declarative understanding of the environment that they're in. And when I say declarative, I mean you're not writing code, you're writing tags. Right? And so for that, we have a number of exercises, and we try to make everything very visual, right? And so one of the things that we do is that we work with shapes, and we work with shapes throughout the entire week. And so we introduced these on Monday, and as you can see here, this is the way in which you declare a shape on an HTML file. Now, the nice thing is that you can, my machine will stay as responsive. Let me see. You can see there the shape, and you have all of this. You have all of this in the repository. And you can see there that although it's a bit cryptic in the way the properties are expressed on that tag, they're not too forward, right? In the sense of, you have position, you have C on the top and left, it's X and Y, you have height and width, right? You have border radius, you have backgrounds, and so on. And so this is something that they can see a connection to, right? So if you change this, by the way, if you remove the radius, it becomes square. So if you do this, then you have a square, right? And you can make it bigger, you can make it smaller, and there's that immediate reward, right? That it's just a text file. You can write it in anything you want, and you can start to interact with it, and you can see that connection back, right? And so let me go back to my slides. And so the goal here is to have them understand that these instructions that you're passing on to the machines are ones that are interpreted, and then you can see them visually, right? There's a few more things, principles to cover. If you have not worked with the graphic systems before, you'll find it weird, right, that y is positive down. That's just the way graphics people have done things. Z-index, you want to show them a picture like this just so they understand the coordinate system of the machine. And then an exercise that you want to give them is this one, right? So this gets them to think about the coordinate system on the page, right? You have a bunch of shapes, you have some geometry there that you're trying to handle. If you notice, there's a certain order, seat order, right, to the shapes, right? Some of them are on top of each other. There's some colors and some other things, right? They're doing everything declarative, right? So if they just copy and paste those shapes, right, they can create this pretty easily, right? And so again, the goal is to introduce them in a gentle way into something that they can have some fun with and they can start to play with. I have since, I believe, well, and this is, well, let me go back to the slides. This is in case, you know, you have them that this hasn't happened yet. But if they just fly by this and they think, oh, this is so easy, then you can start to challenge them by telling them, okay, you know, try to do something a little bit more fun, something like this. And before I get to that, I'll show you what that looks like. Within the folder that says extra, you'll see that I have a number of files, and if you drag them in, you'll see this is just a set of circles, set of shapes, some more shapes, and there's this one as well. And if you look at the code, I'm doing things not in a declarative way now, but well, it might be worth going through it. Yeah. So this one is 4. You can see here that I am, a little bit more space. So these are the ones that I expect them not to get to. But if you see there, I have a div on line 1, right? And then what I am doing later on is that I am getting a handle on that, and I am creating these tags programmatically, and then just adding them to the page, right? So this is a bit of a stretch on that, and for the most part, they quite enjoy creating the shapes and trying to match the exercise that you've given them. And there's a lot of things that are going on here, right? You know, you have an interpreter, you have some instructions that you're passing, and there's a coordinate system that you're working with. There's a geometry that you have to understand. There's a number of things and concepts that you have to absorb. So they normally don't get it, right? But in case they do, here's some extra. And you'll see this in my folders. I have more content on the folder than you will see in the videos. The reason for this is to give you a bigger range of things to work with. As I mentioned, you'll have to pivot in certain cases because certain exercises will not work, right? And it depends on your audience. It depends on how you present it. There's a bunch of factors, right, that come into play. So this is just giving you a richer palette of things that you can work with. Okay, so we're almost at 1 hour, and I've only covered Monday, so I got to speed up, right?
So I think people get an idea of what they're getting into.
Yeah. So I think the hardest, you all have way more capacity than you need to teach any of this. The only thing that you need to do is to gain some familiarity. So download this and play with it, much like we're asking them to do, and look for that thing, that spark of wonder. And you go, oh, cool. Note that, because that's what you want to remember and you want to share with them, right? And so in all of these exercises, we try to find these little cool little things. And so that's what you're looking for. So download it, touch it, play with it, note those things that you enjoy. And when you go back into teaching, hit on those hard because, you know, if you're excited, you have a chance of them being excited. Okay, so that was, let me see, what do I have here? Link to ball exercise, work play, preferences. Well, those are just the cards. And so all the material that I covered through for Monday is in there. Let's go ahead and move into Tuesday. And I'll start off by, oh, and I forgot to mention this. So I'm not quite done with Monday. So there's a project that, because they love to present and they love to build on ideas. And so one of the things that we have as well is a project that runs the entire week. The last hour of the day, that 3 to 4, when they're tired, they've been, you know, doing a lot throughout the entire day. This is when we ask them to start to work on their own project. The very first day, we also shared with them Bootstrap. Raise your hands if you've used Bootstrap. Okay, a few of you, but less than half. If you have not used Bootstrap, it is a templating system that you can download and you can have something that looks pretty good without any effort. And then you can modify it. You can modify it and to create something quite nice. And so, for example, a slider of topics like you often see on websites is something that you can do pretty easily by just switching the images. And this is something actually that on the first video, I have it on there as an exercise because it's fun. They download this, they unzip it, they download a few images, and with, you know, within 2 minutes, they can have a slider or something that's pretty fun to see. And so the reason I mentioned this is because we also introduced the project on the very first day. And we asked them to form teams. And there we haven't been that great in the sense that they've only worked together for a day. It's not that clear, you know, who the stronger students are. And sometimes we don't make the best teams. But I would recommend that you make the teams and don't let them make the teams, because otherwise they're going to go back to the natural preferences. And in the very first day, when you assign teams randomly, you might have most of the strong students in one team and a lot of weaker teams, right? And so that afternoon, you know, you want to do your best at recognizing who has talent and to try to distribute them throughout all the teams and to set out the task for the week, which is to apply one of the algorithms that they saw in the morning session to something of their own choosing. So you can think of it as a pitch that's going to come at the end of the week, but this is something that they work through on their own. And you'll see varying ranges of deliverables here. Some of them will have ISO fully working programs for a recommendation system on books by one group, which, you know, just caught me by surprise. And then some other ones that were just a PowerPoint presentation. All of them exceeded expectations, I would say, from what we were expecting in the first year. But you'll get a broad range of functionality when it comes to actually doing an implementation. And to be fair, they only have that last hour of the day. But on Thursday, which is the day before, at 10 a.m. at night, sometimes they're emailing each other and emailing you, asking you questions, and getting stressed out about the presentations the next day. But they enjoy it, you know, and afterwards they get to relax and be silly and so on. So, okay. Okay, so now we're done with Monday, and now we can move on to Tuesday. If I run out of time, you can just follow the guide yourself, right? But let me see. I am on Tuesday. Let me look for the slides on Tuesday. Okay. Every day has a theme. And the other thing that I'll mention before I talk about the theme is you want to create teams every day. So a fresh batch of teams. But after the first team, the first day you can do it randomly, but the second day you know the students better. And so then you do them yourself. And so typically what I used to do is I used to meet the hour before the class started with the TAs in the group just to go over what worked, what didn't work, and so on. And so that's a good time for your TAs to create the groups, right? And you want to change the groups every day because that way everybody gets a chance to work with everybody else within the class. So that's your start. And then this day's theme is binary search. There is a card game that we do that we pose it as a magic trick, but it's really binary search. And I have some videos on how to do it. Pushpita says that it's very confusing. And because it is very confusing, yeah. So you can see there's the demo and the solution. These are for you, not for them. But once they figure out how to do it, because I mean, it's much like Gail Shapley. You do the trick, and then you ask them to try to replicate the trick, and they can't do it. And then you come back and you show them how it's done, right? And then after you show them how it's done, you ask them to choose somebody from each of their teams as a representative for their teams to be the best one at this trick, right? And so the way the trick works, maybe I should show it. Let's see. So this is me doing the trick. Instructor. We're going to be tracking here the 8 of hearts, but of course you can choose. I'll put it at faster speed, okay? I put it just at the top of the deck, just simply to keep track of it. And then place it on the 16th position from top down. So you can count out 16 cards. I'll go here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Actually, this is the solution. I think the. Then just put that. Well, I'll just let it play. And now when we go ahead and spread the cards right to left, that is going to be in 16th position. Right? So to go ahead and spread these cards. So this is how to do the trick, not doing the trick. Do it more or less distributed across the board. Here's another trick as well. I am protecting the cards at the end because if you choose too far to one end or the other, beyond 16 count, then it doesn't work. So it's a binary search, as you might gather. So I'm simply going to select here in this case the 8 of, or let's choose the 9 of hearts. And but in reality, what you're doing is remember to protect the ends. You do with your hands. Ask your system, please choose a card. So in this case, I'm going to choose the 9 of hearts. I get rid of the rest. And from now on, I'm simply going to get rid of those in the pattern that you saw when I was performing. As you can see here, we get back the 8 of hearts. So there's a few places in where you might make a mistake. The first one is that you don't have the 16th position when you count the cards right. Other is that you have the bottom versus top, and so you get rid of it at the beginning. The other one is, remember, depends on how you spread your cards. I'm doing it with cameras, and actually going right to left. Typically, you go the other way. Just realized it doesn't make sense unless you see it done the other way. Where did my browser go? There it is. Yeah, so this is shorter. I'm going to go ahead and perform a small magic trick here. As you can see, I have a standing deck of cards and just spreading across the page. Please forgive my clumsy handling of cards. I'm not a card player. I'm simply going to spread the cards right to left, as you can see. I'm going to go ahead and spread them out. Try to get them more or less evenly, as you can see. And now I'm going to go ahead and ask my assistant to come over and select a card at random anywhere he likes. So please select the card. So he is choosing this one. I'm going to go ahead and throw out the rest. And now I'm going to go through the process. But the assistant is part of your game. I'm going to go ahead and repeat it. I'm going to go ahead and do it once more. And we're going to go ahead and finally end up with the 8 of hearts. Now, here comes the reveal, right? So you saw this paper that I have here on the side. The assistant picked a card at random. Yet the card that we were left with at the end, as you can see, is the 8 of hearts. Of course, the trick is, how did I do? So anyway, it's again in the spirit of keeping things fun, right? You ask them to try to figure it out themselves, then you give them the answer. Then you ask each of the teams to practice, how to do this. Then you ask them to choose somebody to represent the group, and then they come up and they compete against each other. If you try this, there's a lot of places in where you can make a mistake and it doesn't work, right? So it's great fun because they get nervous, they come up and they're under pressure, and some of them are very fast, but it turns out that it doesn't work, and so it's a fun thing to do, right? Then after that, as I mentioned, the theme of the day is binary numbers, and so this is the fun. Has anybody had this T-shirt? Raise your hands. Oh, come on. Yeah, cool. Yes. Excellent. So this is going to be a binary counting exercise competition that we're going to do with the class. You first teach them the binary numbers. If you're rusty or you haven't seen them before, this is how binary numbers work. You can see here the values, right? And so if they're on, those are the values. If they're not, then they're off. You can see here the numbers of how you would represent them. It's always fun to give them binary 4 because they're shy and they won't raise their hand. They won't do. The first time I went up and there were 2 of them in front, and I said binary 4. Neither of them wanted to raise their hand, right? But 6 is always full, right? So, and so this is one where this is the only activity that we have the whole week where it's individual. Everybody gets to participate as opposed to doing it in teams. Everybody goes up and you can do your numbers and so on. So there it is. Then we ask them to do a binary clock, but we don't give them any instructions. We just tell them, you've seen how binary numbers work. You know how regular clocks work. How would you create a binary clock using what you have learned? And it's fun to see them do it because it's a weird thing to try. And it's not at all obvious, right? And so they come up with all kinds of, I've seen the most interesting range of binary clocks that I've ever seen. MIT students tend to create 4 or 5 variants. They have way, way more, right? Not all of them are right. Some of them, this is the one thing you do. You walk around, in the circles and you check. And sometimes their logic is just not right? But this is part of the process, right? And they go back and forth again. There's 5 of them to a team, and so they're checking each other and they're going through this. And you can see here some of the clocks that they come up with. I like this one most of all because if you've seen any of the videos, you've heard me say that they thought it was a piece of art that they could have in the family living room. And so I liked it most of all because not only did they address the technical challenge, they were thinking about design, right? How this could be used. And that was a pretty neat thing, right? And so you can see there some of the variants. I think the one over there in the upper right is one that I've seen before, but you get a lot of interesting ones. Okay. So then on to the afternoon. The afternoon sort of steps up in MIT style, right? So the first day was declarative coding, playing around with some tags, not really touching at all variables or any of the Turing complete parts of the language. The second day is really touching all of that. So variables, arrays, conditional statements, loops, functions, and so on. And let's see. We start to work on the browser, the developer tools. We go through creating a variable, calling functions. I have also created, and I know I need to speed up, so I'm going to start skipping parts, but I have also created some functions. So if I look at, let me see, this is Tuesday, ball. Yeah, so I believe, if I remember my code correctly, I have a function that creates these little balls. And let me just reload the page so we get it there. And if I do create, you can see there that we get another one, right? And so you might have seen in some of the pictures, some of these, and you can imagine that, you could do a while loop as long as I have to declare I first, because if you haven't seen this before, it's just an interactive console. It has access to the page, and anything that you declare has access to all of that memory and all of that layout, right? And so, and how did I open it? If you haven't seen it before, you select, and this is in all browsers, though we have asked every school to have Chrome. And so if you select more tools and you go to developer tools, that's how you get this, right? And so in this case, I'm just gonna declare a variable. If you have not written in JavaScript, it's worth taking a small tutorial. An hour will cover the basic syntax. You don't need more than that. Now that we have a variable, we can create some shapes. Let's say as long as it's less than 0. I mean,
how many of you guys have already coded in JavaScript? Okay. So for rest of you who have not coded, I think Emil has some tutorials. I can share them. And then I can take a look like how to define a variable and all this. It's just normal, simple JavaScript. Also, they have an editor, I believe, in class, so you don't have to write it.
Yeah.
The terminal, I know everyone loves doing the terminal, but it's kind of confusing. Yeah. So we are every lab to have Chrome browser and VS Code as the editor, but yeah, you can write it in TextPad and text editor.
So just to complete the exercise, you can see there that I made a syntax mistake. While I less than 100. Yeah, I put in the wrong line terminator. You can see there the shapes, and you can saturate the page. And it's a fun thing to try, right? Like Pushpita said, if you want to write the code inside of the file, which is a lot more sensible, you can do this, right? And if you reload the page, why didn't that run? Let's see. Continue to only get 1. That's because we have no I. Bar I equals 0.
Yeah, that's the beauty of JavaScript. Never throws an error.
Yeah.
So if you don't have I, they don't care. So you have to be very careful when you write in JavaScript.
So, again, we're trying to make things colorful, fun. It's fun to try these things, right? Okay, so you can see here also the other functions that are available. So you can resize the ball, you can play with the colors, you can move things around, you can change the z-index of where they are, because all of those shapes that are being created with this create function are doing the same thing that we did in the first page. So they are creating that declarative tag, and they're injecting it directly into the document. So all of these are shapes that you can actually get a handle on, and you can move around, and you can do other things with. So that's pretty much it for this day. And you can see, oh no, I keep on forgetting that there's, so there's also, the concepts of loops, the concept of arrays. And one of the last exercises that we do is that we create the Mona Lisa using, and here, this is one day where I have a lot of extra exercises. So for example, if you look at this one, this is a full binary clock. So this is a functioning binary clock written completely in the same way, right? Again, this is just additional content that you might consider. I have also a binary hand, and considering they competed, this might be fun, right, for them to do or see. If you haven't written one of these before, it's a big conditional statement. And the way you actually would create a number that is bigger than 31 is the way that you would have to write the logic for this. And for example, if I do 6, you can see there that it does the right thing, right? And so I have an exercise there where you could ask them to write it themselves. It might be too much, right? But it's there for you, right? So I have more things in here. This is the card trick. Oh, and the painting. So the other one is you give them an assignment where they have to do a loop within a loop. And what we have is we have an array that has a long list of values that are hex values, right? So many of them. And you have to do a loop within a loop for the right coordinates to do this and go. Right? You've done that before at some point, right? A loop within a loop. And so if you do this right, then here is what you get. Now you get the Mona Lisa, right? And if you look closely, you can see it's little circles, right? Made up of the same shapes, right, that they have been using. And again, you know, it's, the goal is to get them to go, ooh, cool. If you have done transformation matrix and somebody's going very fast, you can ask them to do that. You know, you can rotate, skew, and all these other things. I also have another one there that is another painting. That's, you know, you'll recognize this one, right? So everybody asks me, why are there no colors there? It has to do with how it's generated. So, okay. So that's pretty much it for Tuesday. The last hour every day is going to be the, let's see, is going to be the project, right? And we have documents for every day that gives them some guidance as to what to do. Any questions on Tuesday? No? Clear? Very clear?
So in the curriculum packet, the link is bit.ly/bp-curriculum. There is a set of slides from previous instructors. So this is a lot of information to throw at you. And if you feel overwhelmed or if you can't remember how to open up this Chrome browser, it's screenshot every single step as if you're teaching a class, so you can always refer back to it.
And there's videos, as I mentioned, yeah. Right? And the videos do walk you through all the steps and show you where things are, how to open up the browser, and so on. Raise your hands if you feel overwhelmed and are not shy. Okay, cool. Okay, so as I said, I like to say, let it wash over you, right? Yeah. Just say, okay, it's fine. You know, just okay, so that was Tuesday. And as I mentioned, there's the reason why there's so many extras. I don't expect really anybody to be able to do a binary hand, right? Or a binary clock in code, right, on the second day. But I don't know, it might be something you want to try or show, or it's there for you in case you want it. So the third day, let me close up Tuesday.
So what I did was I went over the logic of the binary clock, some clock, and I posted in GitHub, so you can have the URL and you can just show it to everyone. So that means you have a live app of a binary clock in your phone.
Binary clocks are cool.
Yeah, binary clocks are cool. So you can go home and show everybody, hey, you did this binary clock.
Yeah.
It was posted in GitHub.
Yeah. It's the sort of nice things they can tell their parents too, right? I can count to 31 in one hand, right? So it's nice. Okay, Wednesday. It stops at Thursday, by the way. So we don't have to go.
So it starts Thursday morning.
Okay, so Wednesday, same thing every morning. Create new groups. Again, balance your groups. Try to address any issues that you saw. A lot of it this day is about encoding information, ciphers, and other things. And so there's a little fun exercise here that we do where we ask the students to fill in at random a grid like you see here. And then you tell them, I'm going to make this even harder by adding one more column and one more row. And then I'm going to walk out of the room. You're going to change something, and I'm going to come back in, and I'll be able to tell what you changed, right? So it's another one of these condition type things, right? Now, to them, you're going to do things so that they are odd or even, right, on every column and every row. And so when they change something, you will be able to know, right? And so again, it's you know, it's something that's fun. And you can ask them to demonstrate as well if they understood it, right? Then walking into the exercises of the day, ISBN verification, talking about encoding information. Pretty much everybody's seen an ISBN number, and you can check and see here if it's a valid ISBN number. I don't think it's that exciting, right? Verifying. I don't know that anybody did verification of an ISBN number, but it's there for you. The other one is searching for a number in unordered search with cards. Search for a number linear, that is if you have it organized or not. And some of those questions is, you know, should you order your array before you search it, or should you just search it blindly, right? And some of those questions of complexity and scale, right? The other one is, and this one they love, you know, what's the minimum number of guesses that you have to take to guess a number between 1 and x. And you can see there, you know, of course, you don't show them that, right? You tell them to guess it, to figure it out, and they enjoy doing that, right? Because it's, again, one of those things that that everybody can relate to. Strategies for sorting. Yes, the other thing I asked them to do is to come up with a way of sorting information. This is not an easy thing, right? They don't know that, right? But you just tell them, how would you figure out how to sort things? And they come up with all kinds of crazy ways, right?
Sorting non-speculative within that.
Yeah.
Couple sort downs.
Oh yeah, yeah. Oh, that's right. You had that.
Yeah.
Then we moved into ciphers. Ciphers is one of those things that are fun, right? Because you can create things that other people can't understand. It's sort of a weird notion, the notion of hash functions. And so I started them out with the simplest possible thing you could imagine for a hash function. The type of hash function that nobody would ever write in security, right? Because it doesn't make any sense. But you can see how pretty clearly how would you get to 52, right? And so that is where we start them out, and then we start doing cipher activities. And you can see here some of the examples. We do ROT13. We do, these are examples of ROT13. Then we do rail fence ciphers. I really like the rail fence ciphers in my group. You can see here the encrypted message and how you would decrypt it. And so you can, if you saw the videos, you saw them around the room with boards and them trying to decode, and they compete against each other, right? So again, it's this gamification part of the learning, right? More ciphers. You can see here some of the applications of binary trees. I think I skipped it, but at some point we had binary decision trees and how you could apply it. This person was trying to create here some online site and how to organize their content. The other one, I did exactly what she was doing. But see, there's some of the examples of the binary. Okay. In the afternoon, the pace picks up again. This time it's about simulation, and so we're looking at timers, at coordinate systems, computational geometry. We continue with the same shapes that we saw from the very first day, but now we're moving in time and we're moving in space, right? And so some of the examples that I have here, I'll show you. And these you can make just as the other ones, as complicated as you need to, or as simple as you want. Let me see, that's the wrong day. You can see here my list of examples. So if you have the folder, you can start to look inside. No, that's not the right browser. And you can see what you're trying to do is you're trying to get them to understand. Let me go back to my slides for a second here. You're trying to get them to understand, this is how you do a timer in JavaScript. And you're trying to get them to understand this notion of something being executed periodically and being able to change your geometry based on that, right? So, you know, second 1, you are at 0. Second 5, when it executes again, you want to move 5 places to the right. Then you want to do that again, and you want to do that again, and you want to do that again, right? And so it is a weird thing to do, the very first thing. How many of you have done the move the ball exercise? Raise your hands. Right? Not that many of you. So if you haven't done it before, it's sort of a weird thing to do, and it takes some time to get comfortable with that notion of something, executing something into the future, because that's what you're doing, right? So you're programming something that is going to execute later, and then is going to change, and it's going to execute again, and then it's going to change, and it's going to execute again. So the very first and the least amount that you wanted to do is to be able to move this shape. And again, we're working with the shapes from the very first day, right? And how you get a handle on that shape in this environment, it's on line 3 here, although I have no numbers, right? But you get handle of that shape. And if you remember the properties from the very first day, the style that left, this would be the horizontal axis, right? And because of the environment, you have to attach the pixels. And you can see here that I have some velocity that is really the increase, the increment at which you are moving every time this fires. This part down here at the end, it's simply the amount of time that is going to elapse between calling this function. And there's a ton of concepts here that are more advanced. For example, this is called a callback function. But without getting too deep into it, just the notion of being able to schedule something into the future, to being able to execute it, and to be able to move it is the very first level of this. And it's a hard thing to grasp conceptually, right? And so because of that, it takes them quite a while. And let me go ahead and show you here some of the solutions. So here is the ball, it's moving, and it's the same code that you saw there. And from this, you can start to do all sorts of things. The next thing that you'd want to do is edge detection. This is something that you do in video games, right? So if something's moving along in a graphical environment, you want to know when, video games are always so violent, right? But you want to know when the character gets shot, right? And so you want to be able to detect that geometry. So edge detection is something that is done quite a bit. And so, the solution, is this one just simple? No, this is the next one. This should get to the edge, and it should bounce back, right? And what you're doing, anybody want to volunteer what it is that you're doing to get it to bounce back? Those of you who raised their hands now are regretting it, right? No, I won't pick on you. But all you're doing is you have to detect when you get to the edge, and then you have to change your acceleration, right? So it increases negatively. And then you get to the other axis, and you have to change your acceleration again, and then it comes back, right? But again, it's a very simple piece of code, right? It's very, very small, but conceptually, it's difficult to understand, right? And so once they get through this, and you can give them some times and let them ask questions and so on, then you want to do the exact same thing, but in 2 dimensions. Most people don't get there, right? Because you have to do the exact same thing, but you're handling now 2 more cases, right? And so how do you go through all of this and you switch all of your accelerations is something that takes quite a bit of, to be fair, MIT classes, people who haven't done it before, it takes them, a good 15, 20 minutes to get comfortable with this, right? So you can imagine that for them so let me see, which one is it? Just wanted to show you the solution. So, no, this is me just getting ambitious, right? So you can imagine, that, you start to play with this and you can see that they're at different speeds, right? There's other things you could do as well. For example, you could change speed on hitting a boundary, right? This one's going to change. See? Well, no, this one's change size, right? And then it's going to come back, right? so there's all kinds of conditions. You could really, meaning this could be a very illustrative example that they could really dig into on their own and start to try many different possibilities. And ultimately, you could even do a simulation system that starts to do some of the physics simulations. You could have elasticities and springs and many other things that people get into. And so again, it's at the very basic core, you see something move and it's cool because you haven't done that in the first 2 days. And how far you take it afterwards is really up to them, right? But you can see here some of the possibilities. Ooh, low battery. Okay, so let me speed up. Does anybody have a charger? I have the Mac 13. Yeah.
Yeah,
it's like that. Okay, thank you. So,
oh, sorry. Yeah,
No,
it's pretty sure.
it'll be. So, just untangled.
Oh, I'm sorry.
It's okay. I probably pulled it in the wrong way. Okay, so that is pretty much it for Wednesday. And you can see there the principles are time, their space, their functions, and all of the terms, right? So for example, loops, it's a big deal. If you're asking them to do a simulation and they really don't understand loops, you're asking them to stretch a lot, right? So they may seem very simple examples, but they're meant to be, to inspire them, to get them to ask questions, and hopefully, even if they don't understand it, they can play with it and get to a point where they could do more with it. Okay, so that is Wednesday. We only have Thursday to go. Okay, so
Thursday's half a day.
Yeah, Thursday is half a day, right? So let me close Wednesday. Let me play Thursday. Same thing, create your teams in the morning, information hiding. I think Thursday is a bit of a mix of topics. This is one of those where, say, for example, you wanted to know the average of a table's allowance, for the girls, but you don't want them to say it out loud because it could be embarrassing, right? So how could you do that without them sharing it publicly? And there's some techniques here for seeing how you can do that. Then we get into sorting. Sorting is one of those that I was surprised by because I thought they were going to love sorting. They didn't really care much about sorting. Right? It's like, okay, sorting, cool, right? But I think it's maybe had some of that had to do with me because you said they love sorting, right, with you? Yeah. So she did sorting in terms of dance, right? So that's what I meant about sometimes it depends on you, sometimes it's the way you present it or the group, right? So I had no success with sorting. And one of the ones that I really thought that they would love is bubble sort, because even though if you've seen this sort of thing, bubble sort is terrible. But visually is very easy to see what's going on, whereas some of the other sorting algorithms are not as simple to visualize. Is the dancing one you did bubble sort?
Yeah.
Cool.
Swaps.
Yeah. Okay.
Couple more.
So my idea, by the way, was to order the entire class and give them numbers, a card, and then I would say go, and then they would look at their number, and they were supposed to do bubble sort and try to do all of this. Again,
I think Erica played Macarena on sorting. Who played last time Macarena on sorting? I saw those videos.
Macarena,
The
sort of.
song, and then
Yeah.
you put the sorting to the. It was really fun. I find that because it was really fun. Yeah, I didn't have that choice of music, but I had something else.
So you can see that I think you're sort of getting the pattern now of what we're doing every day. Here's merge sort, sorting, and these are nice. There's some visualizations here to some. Let me click on this. You can see here the different speeds at which they would execute, and you can show them, the impact of this. This is the sort of thing that I think I had no success with. Somehow they didn't care, but I think I saw Randy do it really well. Randy had some amazing visualizations, and they did seem to care. She was asked, when I walked into her classroom, she was asking them the question of, based on your type of data, what would be the best sorting algorithm? Which I thought was a pretty good question. And they were giving great answers, right? So I missed the explanation of how she did it, but then she had the visualizations, and based on the responses, this is something she had herself. She'd be able to run all of them, and they'd be able to see whether their sorting really performed or it didn't, right? And so I think it has some nice potential. Just the reason I shared that mine didn't work is because the material that I have there didn't work, but others had success. Okay.
Somebody did the traveling salesman. I don't know which day did it. I think Thursday, because Thursday is like the last day, and you want to cover stuff that you think will be good to cover, and you could not cover before or something.
We tried.
Yeah, they need string.
Oh, and this was another suggestion of mine, that you could do 2 levels of sorting. So you sort based on category, and then based on the order within the category. And again, whenever you have a lot of people moving around and trying to figure out what's going on, it tends to be fun. But this is an idea I had after the fact, right? But again, a suggestion, me thinking about how I could make it work, right? And when it comes to complexity, this is the example that I gave them. I was trying to get to blockchain, and so I started out with this. I did not do blockchain. Well, I did do blockchain, but it didn't work. It didn't work. So I was, when I did it, this is when I ran the pilot, I threw everything at them, like everything, including blockchain. Right? So in order for them to understand the rise in complexity and computational cost, I started out by asking them these questions, and they all had coins, and they had to flip them and trying to see, how many times you had to flip the coin before you get 5 heads or tails in a row, right? And it's a nice way to explain complexity. Yeah?
I think my class wanted to just write code, and they were like, okay, when is lecture gonna end, and when are we going to go to lab and write code? So last day I did something called Google Map APIs. Like they wanted me to do something funny, and I'm like, okay, let's do this. They could put markers and pointers. So just like some example. I know this is like a lot of content that we have, and it depends like how your students are taking it. So yes, as Abel mentioned, pivot when something doesn't work. You see what the students are liking and not liking.
So I was brutal, right? I mean, I thought the first pilot, and I was brutal. But I gotta say, they did respond, and I think the only one that landed poorly was sorting. But they seem to enjoy it, right? But again, I was always thinking about how do you make this relatable? How do you map it back to something that they see in their real life, right? And so this is one that's very relatable to, much like Gil Shapley, to pretty much everything, because even creating schedules for a restaurant, right, and you have all these different people, they all have different preferences, is something that is quite challenging. And the bus, the bus route, how do you optimize your bus routes and your bus drivers and all of this? Within a city, this is a problem that even the city of Boston and a team here from MIT, from the transportation department, have been writing a program for, I don't know, 10 years, trying to optimize the way they do scheduling for buses here at the city of Boston. So it has all kinds of really great applications. It doesn't have also great solutions, right? But it's a fun problem to see the growth of complexity, right? And you can see here how it rises. Oh, and by the way, I have a bunch of videos as well. Let me point that out before I forget. In the folder. So if you look in here, for example, Gale Shapley, this is the Gale Shapley algorithm, a video, on how to do it. And then I have one on, let's see. Oh, this is them, the girls. So just to show you that they're fun, this is them. They like to sing. Do you know what this is, Graciela? I've never heard this, but it sounded fun.
Yeah, I don't really know, but it's pretty.
So you give them a break, and they burst into song. Seriously. Is this? So she.
Like, oh God, the break.
So this is given the blockchain, So No, but seriously, they burst into song, and they have these games where they sing a part of the song, and the other part of the room sings. And these are people who don't know each other, and they're just singing. And I was so blown away that I was taking video, right? So let's see what other. Oh, and then The other one that we do for complexity is the Towers of Hanoi. Towers of Hanoi explains it better than anything else, and again, it's one of those that is hard to do. And so we ask them to choose a representative from each of their teams, and then they come up, and you can see here's a short one of them trying to go through the exercise, right? Doesn't have audio? It's weird.
We also buy those stationaries and hopefully you will have them in the class.
We get closer and closer. Anyway. Let's see. Here's one of the traveling salesman problem. You know, you can sort of see it there visually, what it is, and video about MIT. Believe it or not, well, you know, but some of them won't know what MIT is. Okay. Yeah. So, so that's it. I think. Let me go back to Thursday and just finish up here. So this was Traveling Salesman, Towers of Hanoi. You can see there a YouTube of Towers of Hanoi. The afternoon is prepare for your presentations on Friday. On Friday, the big event after they do the presentations is mentoring, where they just all sit around and talk to you. Their big question, aside from how did you get into MIT, is what's the big question aside from how did you get into MIT?
How did you really get into college? Like, how did you decide to be in this career? How did you decide to be in STEM? When did you make a decision that you want to go to STEM, or what inspired you to go into software? Like, I'm from software, but not why do I do what I do? Because they have to make the decision very soon in their life now, because they are high school, so either have to go to STEM, what kind of job they will get, might go to STEM. So that's I think the most comfortable.
You'll also be joined by the Mexican TAs, and they have all kinds of great stories. Like, for example, I had a TA who was signed up for fashion, and then the day she went to sign up, she said, "No, I'm going to switch to computer science." Right? and just this story of their being in school and what it's like to be, you know, the one woman in class and all of that. Right? You had a question.
Yes. So I thought that the girls in this program ranged all the way from like grade 1 to high school, or are most of the girls from high school and only few of them are young?
13 through 17. Okay. So middle and high school. Any other questions? You're all too tired? Oh, no. Yeah. Go ahead.
You're from is the 25 students from different age groups?
Yes.
Some of them are 13, some of them are 17.
Right. And it doesn't matter again in the morning, it tends to matter in the afternoon just because, but if they've been exposed to computation, continues to. Yeah.
Do they pay out of pocket or come to at least like a camp?
It's free across the country, but there are costs. For example, they have to feed them, and that's honestly the biggest expense. It costs $100 a week to give them food, right? Because as you'll see, they bring the food and they bring the drinks and all of that. And for the ones that come from the public schools, they tend to be far away, and so they have to bus them in. In some places, they charge $10, which is a tenth of what their base cost will be. But for anybody that requests it, it's free. So anybody across the country that says, I can pay, they're needed without question. And it's self-select as well. They don't have to test them or anything else. So it's, yeah.
Are there certain Spanish words or phrases you recommend me know?
There's a zip file of that conversational type Spanish that would be useful for you. It's the sort of thing that you'll hear at the airport and if you move about the cities, that would be useful for you to know. I'll post it to the group. Yes?
So for the classes that are in English, would the students understand English, or would it always be like we say one sentence?
It depends. What city are you in?
Sub- sub-
Oh, in Guadalajara. That's my sister. So you can answer that. It depends on who.
It depends on the background. It's
Someone-
gonna be like half are gonna master English and the other half will probably not speak very well.
That's in the center of the country. So
Yeah, but the TAs will be very helpful. Usually people speak good English in secondary.
yeah, that's true. So for the most part, it comes to the public-private again. If you had a
Yeah.
private school education, your English will be great.
So every city has a mix of Spanish speaker and non-Spanish speaker. So if the class is to Spanish focus, maybe we shift teachers. So we'll get the girls selected and then we'll see how we can divide them into a proper classroom that fits the instructor's ability.
But we're also in contact with our partners in Mexico, and that's why every single one of you who's been interviewed has been really asked about your level of Spanish, and we've tried to match your level of Spanish with the students' level of English in communication with our partners. So it should work out, and also all the TAs that we're in the process of selecting this week and next, we're asking the same questions, so we know it's going to be. So you need to rely on minimal translation is what I'm saying.
Yeah. Any other questions? Yes.
How is the day structured? Like, what time do you start? In the morning?
Starts at 9.
Start at 9.
They start because the parents bring the kids in, so they start arriving at 8. Like I was normally showing up at 8, and I'd see the moms getting off the bus that came from the outskirts of the city, right, and bringing the little kids, and so they start showing up at 8. But the class starts at 9, and it runs until 5. Although after 4 they're dead. So I tended to call it at 4 and say, okay, tell your parents to come pick you up at 4 because after 4 they just couldn't do anything. They were just too tired. Yeah.
And is their school like off for the summer at the time we're coming, or they're kind of
No,
missing class?
it's this program has enough weight behind it that they take them out of school for a week.
Okay.
Yeah, they're still in school.
Yeah. In fact, there was, which is funny, in Guadalajara, in el Colegio Alemán, there was such a big protest from the parents that all of the girls were going to this great program and the boys were not, that they started their own program at the college based on all the complaints of the parents, just taught by some random person. So, another question? Yes?
Yes.
In terms of where we're staying, how close will we be to? All right, are we staying at the campus?
It varies across the country. Some of you will stay with host families, other of you will stay in hotels, and others will stay on the campus. So for example, in Monterey Tech, Custody was teaching at Monterey Tech, and she was staying on the campus. So she'd get up and just walk over to her class. In Puebla, for example, that I visited, they were staying on a hotel across the street. And in other places, even in Monterey, they were staying with host families, and they drive them every morning to the school. So you don't have to worry about transportation. All of that is taken care of. Regardless of where you are, they'll come get you and drive you to wherever it is that you need to be, and pick you up at the end of the day as well.
Okay, so we will share all the accommodation details in 2 weeks. So give us a couple of days. We'll also share who will come and pick you up. You already should have got the flight details mail from Olivia and Lewin, depending on your grad or undergrad program. Let them know if you have any special timing that we can go travel, not travel. Generally, we are not traveling during evening, so no late night flight, no red eye, nothing. You always travel in daylight. That's also something security-wise. Misty will have a security briefing that is also going to be sadly mandatory, so you will get Misty mail. Griselda will take last time took it. So that will be before we travel. So that will be somewhere in May, end of May before we travel.
That's the mandatory security,
Yes.
like, don't eat street food and those things.
And you have to fill up a Misty form. Okay, so
Don't drink water from puddles.
Okay. Any questions? If you guys can log into Slack, then we can stop sending you 5,000 mails. Sorry for that.
Yeah, please log on to Slack to minimize the email spamming.
Yeah. Go ahead.
About the flight. Is that having the actual it's the phone. Oh, it is the phone.
Yeah.
So the flight form needs to be filled out by Monday at midnight, especially if you are based in Monterrey, because we're booking the Monterrey flights next week on Tuesday.
Yeah,
If you have any questions, you can come talk to any of us.
yeah, there's already a standing right there, and you can talk to her too. Yes, any questions? Yeah.
Don't forget your charger. You're from Wellesley, right?
Yeah.
Okay.